Okay, now section 2.3 is on finding the domain and range of functions. And just to recap, we need to remember that the domain is going to be the x values of your function, and the range is going to be the y values of your function. So this goes with number 1, and I sent these handouts out to y'all on Friday. So I'm just going to go through this 2.3 one. And this is my free-handed recreation of that number 1. So if you have yours out and printed, you might want to look at yours. Yours is probably going to just be more exact. Okay. Now this is going to ask me 4 different things about this graph. Okay. I'm going to kind of do them out of order because I want to find the domain and the range of this graph first, because that in turn is actually going to help us answer the other 2 questions. Now, if you are given a graph and it's asking you for the domain and range, and you just have a group or a set of points that are showing on that graph, the domain just wants to know what are all the x values of those points. The range just wants to know what are the y values of those points. So before I do anything else, I'm actually going to write out the ordered pairs that make each one of these points, starting with this one farthest on the left and then going to the right. And I'm just going to list them out. Now, remember, each point always comes from an ordered pair, and it's going to have an x coordinate and a y coordinate. So let's look at this first point on the left. Where does it line up with on the x-axis? And again, if you have yours out, it's probably easier to look at yours. It looks like it's lining up with the -4 on the x-axis and the y, 1, 2, 3, 4, 5, 6. So that point is at -4, 6. So that's that first point. Now I'm just going to go to the right. This one's at -3, 1, 2, 3, 4, 5. This one's at -2, 4. This one's at -1, up 3. This one's not left or right at all, right? It started right here and it just went up. It didn't go to the left or right at all. So its x coordinate is 0. Its y is 1, 2, 3, 4. This one is to the right 1, up 5. So it's at 1, 5. And this one's to the right 2, up 6. So it's at 2, 6. So there is the list of those ordered pairs that go with each one of those points. So from those ordered pairs, I'm going to list out the domain and the range from this. You remember your domain is your x values. So now that I did a little bit ahead of the problem work, I can just look at these points and name out their x coordinates. If you see any repeats, there's no need to write a number twice when you're writing the domain and the range. So let's see. My x coordinates are all the first coordinates of each point. So -4, -3, -2, -1, 0, 1, and 2. Nobody repeats, so I just write all of those numbers. So starting at -4, -3, -2, -1, 0, 1, and 2. So there's your domain. My range is the same thing, but I do the y values. And again, if I see multiple of the same number, I don't need to write it twice. Let's look at my y's. 6, 5, 4, 3. And then I see 4, 5, and 6. So I see 4, 5, and 6 twice. I just need to write out each one of those numbers once. There's no need to write them twice. So let's see, starting from the smallest number in the range to the biggest. So 3, 4, 5, and 6 are the numbers that are in the Y's. So there's your range. So why is there more in the domain than the range? Is because, remember, your domain is your X values, your range is your Y. There are some points, like these 2 points. Look, what is its X? This one's X is -2. Its Y is 4. This one's X is 0, but its Y is 4. So they have 2 different X's, but both of their Y's are 4. So they have the same range number. So your domain and range don't have to have the same amount of numbers, because some points have a same X or a same Y as another point. Okay, now the other 2 things that this problem asks is, the first thing it's going to say is, what is f of -2? So what this is asking me, if there's a number inside these parentheses like this, this is the X. It wants to know what is f of -2, or in other words, what's going to be the Y number or numbers that goes with the X being -2. So now that you have this written out, you can either look at the picture or look at your ordered pairs. I like to look at my ordered pairs and just go find any point or points that have the X being -2. So if I go, I see this has an X of -2, and that's it. So what is the Y value that goes with that X being -2? Its Y is 4. Then the last thing it's going to ask you is find any X values when f of X equals 4. So what this is asking, first of all, f of X equals 4 and Y equals 4 say the same thing. F of X and Y are interchangeable terminologies. So X values for when, let's just say when Y equals 4. So you're doing the same thing. You can come down to your ordered pairs and see where my Y is 4, what's its X. So let's see, there's a Y is 4. And here's another Y is 4. So what are the X values when Y is 4? The X values are -2 for that one and 0 for that one. So -2 and 0 are what those Y values, or excuse me, the X values would be when the Y is 4. Okay, looking at number 2. So it's going to give me another graph and ask me essentially these same 4 questions: domain, range, and then the other 2. But instead of just being a group of points, it's going to be a continuous graph, not separated points. So this graph goes along with number 2, and I put those points on there for a reason. We'll see that in a minute. Okay, so just like the last one, I'm going to do the domain and range first. Okay, but you'll notice this one is a continuous graph, right? It's not just separate points that I can list out the ordered pairs all nice and neat, like on the last one. Okay, so when I'm talking about the domain, remember your domain is what are your x values of your graph. Now remember the x-axis or x values tell me how far left and right does this graph go. Does it stop ever going to the left or to the right? Or is there holes in it going to the left or the right or anything like that? So when I'm looking at this graph, this arrow says this is going up and right forever. So starting here, it goes to the right forever. It's eventually, if my x-axis goes this way forever, this is also going that way forever. So it's not ever going to miss any x's going that way. Same thing going this way. If this is going to the left forever, it's eventually going to cover that whole x-axis. It's not ever going to stop going to the left. That's what the arrow at the top of that says. Which means your domain is all the x's, right? It's going forever to the left, forever to the right. It's covering the whole entire x-axis without stopping. Okay, there's a couple of different ways that you're going to see this on this particular problem. This is a multiple choice, and it's just going to be stated as the domain is all real numbers. The range. So the range is your y values, or in other words, how far up and down does this graph go? This one does have a stoppage, right? Because what does it do? This is the lowest it's ever going to go. Because on either side of this point, it's just going up. You don't ever see anything going below that point, which means there is a bottom to that range. Now, when you're talking about range, remember, you're only talking about y values. You don't care at all what the x value is. So the y value, this is my lowest point of the range. That's going to be the bottom of it. So let's think about what this point is. It's to the right, 1, 2, 3, 4, 5, but up and down 0. This is the only number I care about is that 0. That's going to be the very lowest y value of this particular graph, right? You're not ever going to see a y being -2. Where is that? Here's where y is -2 or -3. This green V is not ever going to be down there. It's not ever going to go below 0. So how are we going to say that? There's a couple of different ways, and the way that this multiple choice problem is going to say is y is going to be greater than or equal to, right? Because it does touch the 0. It does equal 0. It's just not anything below 0. It's only numbers above 0. So greater than or equal to 0 is what that range would be. Now, just like the last one, it's going to ask those other two kind of questions. The first thing it wants to know is what is f of 2. So I know what the x is. It's 2, right? Anything inside that parenthesis right there is the x. So f of 2. So let's go see, where is the x 2? The x is 2 right here. So from this point, you want to go touch your graph. See where it touches the graph. Anything lined up with that x being 2 is what I need to talk about, which is this point right here, right? That's where it's touching your graph. So what it wants to know is what is the y value of that point where the x is 2? Well, its y value is the one it lines up with on the y-axis, which in this case is 3. And the last part of this one wants to know for what x values is f of x 3? So remember, this is really saying what are the x values when y equals 3? So let's find where y is 3. So y-axis, 1, 2, 3. Here's where y is 3. Anything on this graph that lines up with the y being 3 is what I'm looking for. Because if you are on this horizontal dashed line that I just drawn, aren't you up 3? Your y value is going to be 3 if you are up 3. If you are a point that is up 3, your y value is 3. So let's see, it does it 2 times. It does it here and here. Again, this might be easier to look on yours if you have it. What is this one lined up with? What is its x coordinate? 2. Here's another y is 3, and it is lined up with 1, 2, 3, 4, 5, 6, 7, 8. Right? So the x coordinate of that one is 8. So the points 2 and 8 for the x both line up with that y value being 3. Okay? All right. Now, 3 through the end of this section is asking us simply to find the domain. It's not going to give us a picture of the graph like the last 2 problems. It's going to tell us, like written out, what is the function. Okay? So what we're actually, when you're asked to find the domain, what you're really trying to do is find anything that needs to be left out of the domain. What would not work if you plugged it in for the x? Or if you plug in a number for x and it gives you some kind of restriction. Here's the restriction I'm talking about. What happens if you type that in your calculator? 5 divided by 0. And hit enter. It's going to tell you there's an error. You cannot divide by 0, right? That is undefined. You can't divide a number by 0. So that is going to help us figure out how to find these restrictions. What if I have a function and it's a fraction and it's got an x in its denominator? That means there's going to be at least one number that I cannot plug in for x. Let me show you what I'm talking about on number 3. It says find the domain of this function. F of x equals 6 over x plus 14. So I have a fraction and I've got an x in the denominator of this fraction, which means there's a number. When you plug that in, it's going to make that undefined. You're not going to be able to do 6 divided by 0, right? So what I need to do, and a lot of you can probably look at this one and see what that number is that turns that into 0, but you're not always just going to be able to look and tell. So the step that you say is, okay, x plus 14, which is my denominator, cannot equal 0 because that would make that undefined. So just set up that denominator to not equal 0, but then just solve it like a regular equation. Get rid of that plus 14 with a minus 14. You got to do it to both sides. So here, there's your x. Cannot equal 0 minus 14 is negative 14. So that's the number that you cannot put in your calculator. Because if you do, what does that turn the denominator into? It turns it into 0. Oops. Yeah, I'm going to show you something on the calculator. So look, I put that function in the y equals 6 over x plus 14. Now I'm going to look at the table. Look what it does when x is negative 14. It gives me an error message. And again, all the other numbers are fine. There's no other number that's listed on here is going to give you an error message besides that negative 14, because negative 14 is the only thing x can't be. It can be anything else. Negative 14 is what turns that into 0. So when you're looking at this is it'll be another multiple choice. It's just going to say x is a real number and x cannot equal negative 14, which means it can be anything else but that number. Okay, now to simplify this, in this section, the only thing that's going to give us a restriction on our domain is if there's an x in the denominator of a fraction. So when you're looking at ones like number 4, you have p of x equals 2x minus 5. It wants us to know the domain. So think about this. Is there an x in a denominator anywhere? There's not. There's not even a denominator. So this right here, think about what you're going to be doing for any number that you choose to plug in for x in this function. You're going to have to multiply it times 2 and then subtract 5 from it. If you can think of a number that is impossible to multiply times 2 and then take 5 away from that answer, let me know. Because you are not going to be able to find that number, right? You can multiply anything times 2. There's no restriction on that. You can subtract 5 from anything. There's no restriction on being able to subtract 5 from a number. So this one is just going to be x is a real number. There's not any restrictions. Okay, same thing with number 5. P of x equals x squared plus 2. X is a real number again, right? Because there's not any restrictions. Whatever you're going to replace this x with, the 2 things you're going to have to do to that after you replace the x with a number is square that number, which just means multiply it times itself. And you can do that with all numbers, and then add 2 to it. You can do that to all numbers. So again, x is a real number is what would go with that. All right, but number 6. G of x equals 9 over 6 minus 5x. So I'm going to have a restriction on this one, right? Because I have a denominator and there's an x in that denominator. I don't care what the top of the fraction is. I'm just worried about the bottom, because what can you not, this line means divide by, and what can you not divide by? You can't make that equal 0. Okay, this one's not as simple to just look at and figure out what the answer is. So this one, remember, you just set it not equal to 0, but then solve it just like a regular equation. So in other words, I need to get rid of this positive 6 by subtracting 6 off both sides. I still have negative 5x. Cannot equal 0 minus 6 is negative 6. Still solving for this x. Divide by exactly the number that's hooked on. You don't change the sign or anything. That cancels that. There's my x. Bring down my cannot equals. A negative over a negative turns that positive, and 6/5 just doesn't reduce. So positive 6/5 is what x cannot equal. It can be anything else in the world though, right? So x is a real number and x cannot equal 6/5. All right, number 7. P of x equals the absolute value of x minus 4. Oh, wait. Yeah, absolute value of x minus 4. All right, first of all, I don't see a fraction, so I'm not going to have any restrictions. Think about where you're going to be plugging in numbers. You're going to be plugging them in for this x and then taking the absolute value of that number. So it doesn't matter what you put inside an absolute value symbol, you're going to be able to take the absolute value of it. Doesn't matter if it's positive, doesn't matter if it's negative, doesn't matter if it's 0, doesn't matter if it's a decimal, a fraction, it doesn't matter. You can take the absolute value of any real number. And then you can subtract 4 from it. So again, x is a real number, any real number. And the last one of this section. Same kind of thing. X to the third minus 9. So if I'm replacing this x with a number, the first thing I have to do is multiply it times itself 3 times and then subtract 9 from it. I can do both of those mathematical operations to any real number. So once again, that x is also a real number. All right, so that's the end of 2.3. We have 4 sections to cover this week, so I am going to also go over 2.4 also today. Now, when we get into 2.4, it's going to give us 2 functions and then ask us to do some kind of mathematical operation with those 2 functions. It may ask us to add them together. It may ask us to subtract them. May ask us to multiply them. Just whatever it asks us to do, that's what we're going to do. So on number 1, my first function that it gives me, my f of x, is x squared minus 4. It gives me another function and it calls it g of x, and it is x minus 3. And it says to find f plus g of x. Another way to write this, and I think it is more clear, is this one, it's the same thing as finding f of x plus g of x. These 2 things say the same thing. I feel like this is clearer of what it's asking me to do. It essentially is just asking me to add the 2 functions together. What is f of x? Well, here's my f of x. It's x squared minus 4. It wants me to add that to my g function. My g function is x minus 3. The word add is just a real simple way to say combine the like terms. So I'm looking for any terms that are like in this result. In other words, they have to have the same variable and the variable has to have the same exponent. So it looks like the only terms I can put together is that -4 can be combined with that -3. There's no reason to write those two terms separately when you can just as easy put them together. So let's see what we have left. We've got x squared, then my plus x. Then I'm putting these together. -4 minus 3 gives me -7. So I just wanted us to add those two functions together there. All right, number 2. This time my f of x is x squared minus 3. And my g of x is x minus 2. And it wants me to find f times g of x. Or f of x times g of x. So let's see, f of x is equal to, here's my f function, x squared minus 3. My g of x is x minus 2. So now I see I'm multiplying this times this. I need to put parentheses around this so I can see exactly what I'm doing, because I want to multiply this entire function times this entire function. Now that I see it written out like this, if you are fairly recently out of high school, or you remember when you were in high school and you took algebra, you probably learned this acronym, FOIL. FOIL is an acronym for first, outer, inner, last, which is what you use when you're multiplying two parentheses together. And those two parentheses both have two terms in them. Okay, so again, this just stands for first, outer, inner, and last. So essentially what you're doing is you're just distributing. You're going to distribute this x squared to both of these. That's your first terms in each parentheses, and then your very far outer terms of the parentheses. So let's see what that gives us. X squared times x to the first power. And here's the reason I wrote that little 1 there, because that's what's assumed to be there. If you don't see your exponent, it's automatically a 1, because when you multiply x's together, you got to add their exponents. So x to the second times x to the third, x to the first gives you x to the third. X to the second times -2. Now, when you multiply a letter times a number, it just hooks them together with the number in the front. So x squared times -2 just gives me -2x squared. Again, multiplying a letter times a number just hooks them together, and you generally put the number in the front. So there's my first and my outer. Then the next part is the inner and the last, which is just distributing the -3. There's your inner and there's your last. So let's see, -3 times x, again, multiplying a number times a letter just hooks them together. So -3x, -3 times -2, negative times a negative gives me +6. Now, I am looking to clean this up. It's just that when I see all these written out like this, I don't see any terms that have the same exponent. So I can't put any of those together. So that's just the final answer. That's as far as you can go with that. All right, that was number 2. Let's look at number 3. F of x is x squared plus 1. G of x is x plus 3. But it wants us to find g times g of x. So I don't even care about f at all. Because what does it want us to find? G of x times g of x again. So let's see, g of x is x plus 3. So I'm just multiplying the x plus 3 times itself, just like that. X plus 3 times x plus 3. So again, I'm going to use that FOIL method. Here's my first and my outer, which is essentially just distributing that x. X times x gives me x squared. X times positive 3 is positive 3x. This inner and last, which is just distributing this 3. 3 times x, again, just gives me another 3x. And positive 3 times positive 3 is positive 9. So let's see. Now I can clean this one up a little bit, right? Look at these x's. There's no reason to write 3x and 3x when that's just the same thing as writing 6x. Why is it not 6x squared? How did I get this x squared? I did x times x. That's how you get x squared, is by multiplying x's together. I'm just adding these together. I don't have 3x and 3x when I can just say I have 6x. So that's how you write your final answer. You just bring down the x squared, put your x's all together in one basket, so you have 6 x's plus 9. Right, number 4. F of x is negative 13x plus 12. G of x is x squared plus 13. This time it wants me to find f of negative 3 plus g of negative 3. So here's what you're going to do. Since these aren't x's, I can't just use what's given to me. So if there's numbers in here, I need to find these two things first. So f of negative 3 means to go to your f function and replace its x with negative 3. Then I'm going to do the same thing over here. I'm going to go to my g function and replace its x also with negative 3. And then that's going to give me 2 solutions, and then I'm going to add those 2 solutions together. So let's start here with f of negative 3. I go to my f function, replace its x with negative 3. So I have negative 13 times negative 3 plus 12. Now remember, if you type this right in your calculator exactly like it's written, it'll do all the steps for you in one step. Okay, So I'm just going to do it in 2. Negative times a negative gives me positive 39. Bring down that plus 12 and 39 plus 12. Let's see, 9 gives me 51. We'll do the same thing over here. Now I need to find g of negative 3. So I'm going to replace the g function's x with a negative 3. So if I do that, I have negative 3 squared plus 13. Be careful when you type in negative 3 squared. If you're going to square something in your calculator, make sure whatever you're squaring, especially if it's negative, is in parentheses. If not, it's going to give you the wrong answer. Okay, negative 3 squared is positive 9. Bring down my plus 13, which gives me 22. So here's f of negative 3, 51. G of negative 3 is 22. This tells me whatever's in between there is telling you what it wants you to do with your 2 answers. So this time I'm going to add them together. So let's see, 51 and 22 gives me 73. Right, number 5, same kind of problem. F of x is negative 8x plus 20. G of x is x squared plus 16. Wants me to find f of 4 minus g of 4. So I'm going to do the same thing. I'm just going to subtract my answers at the end instead of add them like I did on the last one. So finding f of 4 first. So here's my f function. I'm going to replace its x with a 4. So f of 4 gives me negative 8 times 4 plus 20. Negative 8 times 4 is negative 32 plus 20, which gives me negative 12. Again, you punch that in your calculator right there, exactly like you see it. It's going to do all that for you. Now I need to find g of 4. So replacing my x in the g function with 4. So I have 4 squared plus 16. Well, 4 squared is 16. Bring down that plus 16 to get 32. So here's f of 4, there's g of 4. Now I just need to look back and say, okay, what does it want me to do with that? Once we just subtract it. So this time I am subtracting that. So in your calculator, if you want, negative 12 minus 32 gives me negative 44. Right, number 6. F of x is negative 11x plus 5. G of x is x squared plus 14. And it wants me to find f of 1 times g of 1. So just like the last one. I'm going to find f of 1, I'm going to find g of 1, and then I'm going to multiply my answers together since this one says to multiply. So f of 1, so I'm going to go to my f function and replace its x with a 1. I have negative 11 times 1 plus 5. Negative 11 times 1 gives me negative 11. Bring down my plus 5. Negative 11 plus 5 gives me negative 6. So there's the first one. Now I need to find g of 1. It's over here. So I'm going to go to my g function and replace its x with a 1. So I'll have 1 squared plus 14. 1 squared is 1. Plus 14 gives me 15. So I have negative 6 and 15. And I just come back and say, okay, what does it want me to do with those? The operation it wants me to do is multiply them together. So negative 6 times 15 gives me negative 90. Right, number 7. F of x is negative 11x plus 17. U of x is x squared plus 11. Same thing. I'm going to find f of negative 2 and g of negative 2, and then I'm going to divide them or put this answer over this answer and see what I get. So find f of negative 2 first. Here's my f function. I'm going to replace that x with a negative 2. So I have negative 11 times negative 2 plus 17. Negative times a negative gives me positive 22. Bring down my plus 17. 22 and 17 gives me 39. Do it with the g now. I'm replacing its x with negative 2. So negative 2 squared plus 11. Negative 2 squared gives me 4 plus 11 gives me 15. So what does it want me to do? Put the f answer, which is 39, over the g answer, which is 15. Now, if this simplifies, you have to simplify, right? You just made a fraction. So if it's not in lowest terms, it's going to mark it wrong. Remember how to do the fractions like this. If you're not good at it or not sure if it reduces, type in exactly what you see. 39 divided by 15. Remember, it's going to give you a weird decimal. But remember, how do you turn this fraction into its simplified version? Hit the math button and then hit enter twice. Enter, enter. So that you notice that that one does reduce to 13 over 5. Number 8. F of x is negative 2x plus 4. G of x is x squared plus 5. Wants me to find f plus g of x. So it's just like what we were doing at the very beginning, actually, right? This is the other way to write this is f of x plus g of x. So let's see. There's my f of x. So I'm doing f of x, which is negative 2x plus 4. I'm going to add that to my g of x. So my g of x is x squared plus 5. And then clean it up by combining like terms. So the terms that are like would be this 4 can go with that 5. Right? The other terms don't have anybody that's like them, so they're on their own. Now remember, when you are writing your answer, just math etiquette always says that you always start your answer with the one that has the highest exponent and then go down from there. So my term that has the highest exponent is that x squared. Then I have the minus 2x. And then I put my 4 and 5 together to get positive 9. Right, number 9. F of x is 5x minus 9. G of x is 2x minus 5. It wants me to find f minus g of x. Or again, like I like to see it, that really is the same thing as finding f of x minus g of x. So my f of x function is 5x minus 9. Now, when you are subtracting, I want to subtract this whole thing, the whole g of x. So minus, let me show you how not to write it. Minus 2x minus 5. Just writing it like that is not going to get you the right answer. This tells me instead of subtracting this whole function, I'm just subtracting 2x. I want to subtract that whole function, not just the first part of it, the whole thing. So I need to put parentheses around that. This tells me I'm going to subtract the whole g of x function instead of just the first part of it. So before I can clean this up, what I'm going to do is if I have a minus touching some parentheses, that means to distribute it. When I do that, I see I have 5x minus 9 here. Then that turns that to minus 2x. But look what it turns this into. A minus and a minus together actually turns that into plus 5. So if you didn't put that in parentheses, that wouldn't have changed to plus 5. Now clean it up by putting the like terms together. So let's see, I can put the 5x and the minus 2x together, which gives me 3x. And I can put the negative 9 and the positive 5 together, which gives me negative 4. So just be careful on the subtracting ones. Make sure if you're subtracting a function that you're subtracting the whole function by putting parentheses around it. So the same thing's going to happen on number 10. F of x equals negative 5x plus 2. And g of x is x squared minus 5. And we are finding g minus f of x. Also note on this one, look, if I wrote this out the way I like it, what is it going to say? It's going to say this one first, g of x minus f of x. So be careful here. You got to do this in the order that it tells me to do it. It wants me to do g minus f. So my g function is the x squared minus 5. And if I'm subtracting, I want to subtract the whole f function. So minus, then I'm going to open the parentheses and put in the parentheses negative 5x plus 2. Again, I've got that negative touching a parenthesis, so I've got to distribute it through before I clean this up. So I'll just bring this down, x squared minus 5. I distribute this one, it's going to turn that into a positive 5x. And then it distributes here and turns that into a minus 2. Because when you distribute a negative through a parentheses, it's just going to go through there and change all the signs in there. Then clean this up. Let's see, who's going to go together? Like terms are going to be the negative 5 and the negative 2. Nobody goes with x squared, so I'll just bring it down. Then my 5x. And then I'll put the negative 5 and the negative 2 together, which gives me negative 7. Number 11. F of x is x squared minus 12. And g of x is 12 minus x. Wants me to find f minus g of negative 10. So we were doing this earlier. Remember how we like to see it? When I say we, I mean me. F of negative 10 minus g of negative 10. So I'm going to replace the x's in the functions with negative 10s, and then at the end, I will subtract my answers. Be careful on this one. There's several instances that are prime for sign mistakes. So let's find f of negative 10 first. Here's my f function. I'm going to replace its x with negative 10. So I'll have negative 10 squared minus 12. Negative 10 squared gives me positive 100. Minus 12 gives me 88. Now I need to find g of negative 10. So I'm putting a negative 10 here. Be very careful here. You're going to have 12, and then you're going to have this minus, and then what are you going to replace this x with? What are you replacing the x with? Negative Again, anytime you're subtracting a negative, that really means that you are adding. And if you punched it in your calculator, did 12 minus negative 10, it would do the right thing. 12 plus 10, which gives me 22. Here's my two answers. The operation that it wants me to do is subtract them. So 88 minus 22 gives me 66. All right, number 13. 12, number 12. F of x is x squared minus 15. G of x is 6 minus x. It wants me to find f times g of c. You're going to do exactly what we've been doing. Or f of c times g of c is the other way to write it. So I'm just replacing the x's with c's. So how do I find f of c? I go to my f function and replace its x with a c. So instead of x squared, I'll have c squared minus 15. Then I'll find the g function and replace its x with a c. So I'm finding g of c. So I have 6 minus, instead of x, it's c. Now here's a weird part. What does it want me to do with my two answers? It wants me to multiply them together. So what am I multiplying together? C squared minus 15 times 6 minus c. So just like earlier, we're going to be doing that FOIL. This one's weird though. So I'm going to distribute the c squared to both of these. So let's see. The first thing I have is c squared times 6. So when you're multiplying a letter and a number, you just hook them together. C squared times 6 gives me 6c squared. Careful with your sign here. Positive c squared times negative c. So I have a positive times a negative, which is automatically a negative. And then what is c squared times c gives you c to the third. And then distribute the negative 15 to both of these. So a negative 15 times a positive 6 is negative 90. Negative 15 times negative c. A negative times a negative makes it positive. 15 times c is just 15c. Now, there's no like terms to combine, but you will notice on this one that it is going to say type the polynomial in descending order, which means it wants the highest exponent to come first, and then it wants the exponents to come down from there. So my highest exponent is this c to the third, and it's negative. So when I move it up here, I move it with its sign. So negative c to the third, then my positive 6c squared, then my positive 15c, and then my constant, which is the number that doesn't have a letter, minus 90. Right, number 13. We're going to make it. f of x is x squared minus 3. G of x is 1 minus x. Let's see, what does it want me to find this time? It wants me to find f over g of negative 3. Or f of negative 3 over g of negative 3. So f of negative 3, let's find what that is. So go to my f function, replace its x with negative 3. So I have negative 3 squared minus 3. Negative 3 squared is positive 9, minus 3 is 6. Be careful here. G of negative 3. We replace this x with negative 3. So I have 1 minus, there's the minus that I'm talking about, is this one. Now I'm replacing that x with negative 3. So once again, what does minus and negative mean? You're actually doing, you're actually adding. So 1 plus 3 gives me 4. And it wants me to put my f answer over my g answer and reduce it. So if I put 6 over 4 in my calculator and math enter that. So 6 over 4, enter, math, enter, it does reduce it to 3 over 2. Three more. Okay. On the next one, number 14, it's going to give us two functions. F of x is x squared. G of x is 10x minus 10. Now, I'm going to simplify this as much as I possibly can. It wants to know what is the domain of the sum, what is the domain of the difference, and what is the domain of the product of these two functions. So think about this. The sum would mean you're doing what? Adding those two together, which means just combining like terms. The difference, which if I did that, I'll do this one out. X squared, if I'm adding it to that, I'm adding it to 10x minus 10. Here's the sum of those two things. Is there any restrictions on that domain? Or in other words, do you see any denominators that have x's in them? Just like we were doing at the beginning. There's no denominator. There's not going to be, if you're adding two things together and neither one of them is a fraction, you're not going to end up with a fraction. Same thing, if you are, so that would be the sum. The difference would be this one minus that one. If you are subtracting and you don't see any fractions when you're subtracting, you're not going to end up with a fraction. Same thing if you're multiplying. If I multiply that times that, if you don't start off with fractions when you're multiplying, you're not going to end up with fractions. So in other words, the sum, the difference, and the product are all going to have the same domain. If there's not any restrictions on either of your functions, which there's not, right? You can plug in any number there for x. You can plug in any number there for x. Then your domain is x is a real number. You're not going to all of a sudden come up with restrictions on your domain by adding them, subtracting them, or multiplying if neither one of your functions had restrictions in the first place. So all three of those answers would be x is a real number. I think this may become more clear when we do number 15. Number 15, f of x is 1 over x minus 3. G of x is 7x to the third. And wants to know the same thing. What is the domain of the sum, the difference, and the product? So all I really need to do is look at my two functions. Does one of them or both of them have a restriction? This one's got a restriction, right? It's got an x in its denominator. That means if I add these together, or if I subtract these from each other, or if I multiply these together, that's still going to be the denominator. So this is going to be whatever restriction this gets is going to be the restriction on all three of those. So I need to find out, because x minus 3 cannot equal 0. Solve for x. So add the 3 to both sides. So x cannot equal 3. So that's the restriction on all three of these. X is a real number and x cannot equal 3. When you were typing this in to MATLAB, you know, down at the bottom, all those things with the blue boxes, when you're typing in your answer, one of those things is going to have this symbol in it for you to use on those answers where you have to type in x does not equal. It'll have it down there for you to use. All right, last one. F of x is 3x minus 2. G of x is 2x minus 14. And it wants me to find the domain of f over g. So let's see, if I put f, my f function over my g function, what am I going to have? I'm going to have 3x minus 2 over my g, which is 2x minus 14. It wants to know the domain of that. Now remember, I don't care if I'm just asking about domain, I don't care anything about the top. All I'm concerned about is that denominator cannot equal 0. So when I put the f over the g, it made the g be the denominator that I needed to set up to not equal 0. So I'm going to add the 14 to both sides. Get rid of that minus 14. So 2x cannot equal 14. And then divide by 2. So x cannot equal 7. So x is a real number and x cannot equal 7. So on those, you would be choosing this one. X is a real number, and that's when you would just use the x from your keyboard, then look down at the bottom in MATLAB, and you will see that does not equal sign. Okay, hang on. Let me take roll real quick. Andrew Holcomb, I see. Brittany Honeysuckle. Emma Mitchell. Quet Williams. Gage Jones Webb. Hope Garrison. Joanna Jordan. Haley Smith. Healy Cox. Kevin Patel, Tanya Singleton. Oh, I don't need to be recording all this.